Today we get to learn about adding and subtracting polynomials. Our first vocab word, the polynomial. You can go ahead and write these vocabulary words at the top of your paper. Poly means many. And so a polynomial is a number with many terms inside it. A term, our next vocabulary word, are parts of the number that are separated by pluses and minuses. So you'll know when one term ends and another begins because you'll see a plus or a minus. So 5p squared is the first term, and then a minus happens. So you know here's the starting of a new term. That -3 is the second term. Then there's a plus, so that shows you that a new term is happening. So 2p squared is our third term, and now there's a minus, so -p to the third is our last term in that polynomial. Now this is kind of a long polynomial, and we can simplify it by adding up the like terms, so that's what we're going to learn today. Let's talk about what makes a like term. So at the top of your page, go ahead and write like term. And something is a like term if it has the same variable, so the same letter, and it has the same exponent. You have to have the same variable and the same exponent if you're going to be adding them, because that's what makes like terms, and only like terms can be added. So let's look at the 5 and the p and the square. The variable is the p and the square is the exponent. So it cannot add to that -3 because the -3 is not a term with a p or a square on it. But look over here, 2p squared, that ends exactly the same. It's got a p and they both have a square. So let's circle these two terms, because we know those are like terms and those can go together. Now when they go together, the numbers at the front, those are called our coefficients. Our coefficients can add up. So 5 plus 2 is 7. And then what happens with the p squared is it just stays the same. So you'll write it as p raised to the second power, like that. Okay. If you are typing this, you can type right onto this document, but you would type a 7 and then you would type a p, and there's really no way to raise it. So you will put that little up key, which is Shift 6, and then you would put a 2. So 7 up 2 would be the same as 7p squared. So that's how you would type it, and this is how you would write it if you're writing on it. Okay, now the p squareds are done because there aren't any more p squareds. We can cross them out so that we know that we don't have to deal with them. Now, here's a -3. That's a plain old number. It doesn't have a p. The other term that's over here is -3p to the third power. These cannot go together. We can't add them up because they're not the same, but we can't forget about them either. So I'm going to bring down my -3, and I'm going to bring down my -3p to the third power, and I'm going to write it like this, -3p to the third power. Now this is fine. It's all correct. It's almost as good as it gets. The thing that you can do to make it better is put it in standard form. And standard form happens when you go from the biggest exponent to the second biggest exponent to the lowest exponent. So you go in descending order. So if I was going to write this properly, I would take first this last term, which is -3p to the third power. I'll write it over here. So -3p to the third power. And then the second power is the next highest, so it's plus. Let me make that look more like a 3. So we'll put plus 7p to the second power. And the very last term that we haven't used is the minus 3. So now here it is all in descending order. Third power, second power, no power. And that's good to go. That's perfect. Okay, let's try another one. But I'm going to show you what happens when you subtract. When you subtract, you need to realize that you're taking away not just the 3a squared, but you're taking away also the other term that follows it, which is the negative 4a to the third power. So you have to apply this negative to the first term that follows it and the second term that follows it. I'm drawing these little arrows to remind myself that I need to switch the signs of those numbers that follow. So 3a squared becomes negative 3a squared. And negative 4a to the third power, a negative times a negative is a positive, so it becomes positive 4a to the third power. And so that's how that second parenthesis changes. And you have to remember to do that whenever you see a minus. Notice I didn't have to do that in number 1 because there was a plus between the two parts of this. So I was adding now. Here I'm subtracting, and that's the difference. So a to the third power comes down, and the minus 2a squared comes down. And now I'm ready to do what I did before in number 1 and combine our like terms. The first thing I want to do, though, is find the highest power, because remember, before we added them all together with the like terms, and then we had the last step where we had to put them in order. Instead, I'm going to look here and say, okay, where are my highest powers? And I'm going to go there first. This was an a to the third power, so 3 is a pretty big power. I'm going to look and see if I have any other a's to the third power right here, and I do. So this a to the third power plus 4a to the third power can be combined, and they'll be my highest power, so I'll do those guys first. Remember, if there's nothing in front of a variable, there really is a 1. So this is 1a to the third plus 4a to the third. Remember, those coefficients can add together, those numbers that are in the front of the variable. So 1 plus 4 is 5. And then remember, the variable and the power just stay the same. You can kind of think of the variable and the power as being like a label. Like if I say here I've got 1 apple and I'm adding it to 4 apples, I now have 5 apples, right? They didn't change into something else. So I'm not going to change that exponent. It's just going to stay the same, like a label stays the same after you add stuff together. Okay, so now I've done the third power, so I'm going to cross out 1a to the third, and I'm going to cross out 4a to the third because they're done. And I've got negative 2a to the second power minus 3a to the second power. Negative 2 is the coefficient, and negative 3 is the coefficient. Since those variables and powers are the same, we got like terms, so they can add together. Negative 2 plus negative 3 is negative 5. So I'm going to go put the negative 5 down there. And remember that the powers, or the exponents, powers and exponents mean the same thing, don't change. Remember, they're like labels. So if you were thinking of this as like apples before, these are oranges. A to the third and a to the second are different, right? That's why they have to stay separated. But that's also why these don't change when you bring them down. Add up the coefficients, but keep the variables and the exponents the same. Okay, that one is done. All right. Now, you have an example for you to do on your own right here in number 3. Number 3 is like number 1. And number 4 is like number 2, like we just did. So let's go ahead and review number 5. Look and see what you've got here. Do you see in the middle you've got a minus? Like number 2, we had to distribute that negative. So I'm going to draw the arrows going from negative, from the minus to the 4, from the minus to the 2, a squared. And then I'm going to rewrite them with their new powers, with their new signs. So that's really a negative 4, and that's really a negative 2a to the second power. Then let's bring down the first parenthesis, which doesn't change. It's only the parenthesis after the minus sign that has to change. So I'm just bringing it down as it is, 3a squared plus 1. And now I'm going to go look for my like terms. My biggest power, if I scan the line, is that a to the second power. So here's a 3a to the second power, and here's a minus 2a to the second power. Those are like terms, so I can add up those numbers in front, those coefficients. 3 take away 2 is only 1. I can write the 1 right here if I want. I don't have to, because we know that if we have a variable, there's really a 1 in front of it. But I will, just to be clear, that that's 1a squared. Now that's done, and we can cross them out. But we still have these two. These are both plain old numbers, 1 and a negative 4. 1 take away 4 is negative 3. So just bring that down. Notice the powers. The largest power is first, and it just goes down from there. So it is in standard form, and that's all good. Okay, let's do number 6. We're going to distribute the negative. So that becomes negative r to the 4th. And the negative times a negative makes a positive. So that's a positive 5r to the 3rd. Like I said before, the first parenthesis doesn't change. The one that's before the minus sign doesn't change. So even though I change the second, the first one comes down like it always was. So that'll be 4r to the 3rd plus 3r to the 4th. Now let's find our largest power. There's an r to the 3rd. There's an r to the 4th. There's another r to the 4th. It looks like our highest power is r to the 4th. So let's do the r to the 4th power first. Let's underline those. Remember that if there's nothing there in front of that variable, there's really a 1. So 3 take away 1 is 2. I got to add up those coefficients. 3 take away 1 is 2. But remember that the variable, the letter, and the exponent, the power, doesn't change. So that's 2r to the 4th. We'll cross these guys out because we're done with them and we don't want to worry about them anymore. Now we've got our 4r to the 3rd power, and look, this last term is 5r to the 3rd power. They're the same power, they're the same variable, so they're like terms and we can add them up. 4 plus 5 is 9. So plus 9, and remember, like we did before, the letter doesn't change and the power doesn't change. So it's still r to the 3rd. And the biggest power is first, followed by the second biggest power. So this is in standard form and it's all good to go. And that one's done. Okay, now come down, look at number 9. Number 9, first of all, the sign in the middle says add, so I don't have to change anything. I'm just looking for like terms. My highest term in this first polynomial is k to the 4th power. If I look in the second polynomial that I'm adding to it, negative 3k to the 4th, those are like terms because they're both k to the 4ths. So I can add up negative 4 plus negative 3. That gives me negative 7. And remember, the letter and the power doesn't change. So it's still k to the fourth. We'll cross these guys out because we're done with them. We used them. My next biggest power looks like it's going to be k to the second power. So we'll circle that because we're going to use it now. And here's another k to the second power. So we'll use that next. That has a 3 coefficient. And then we're going to take away 14. You can use your calculator if you want. But 3 take away 14 is negative 11. And it's k to the second power. Let's cross these out because we're done with those now. And the last thing I have going right here is a 14 and a negative 8. Those are just plain old numbers, and plain old numbers can always add together. They always make like terms. So 14 take away 8 is just 6. So that's going to be plus 6. And that one is done. Notice that my process wasn't any different, just the polynomial was bigger, so I had more terms to add together. And that's what we'll see over here with number 10. We have a minus right here in between the two parentheses. That means we're subtracting this second term from the first one. So I'm going to draw arrows from this first minus sign to the first term, and to the second term, and to the third term. And then all these little terms inside that polynomial need to change their sign, just like we did before when we subtracted. Negative times a negative is a positive, so that becomes a positive 6 n to the fourth power. Negative times a negative is a positive again, so that becomes a positive 3n. And negative times a negative is a positive, so that becomes a positive 8n to the fifth power. Remember that the first polynomial before the minus sign doesn't have to change its sign. So I'm going to bring those down as 3 and negative 6 n to the fifth power and negative 8 n to the fourth power, not changing anything, just bringing it down so I can start adding my like terms together. My biggest power, if I scan the lines, looks like it's a 5. 5's my biggest exponent, so let's circle these. I'm going to circle the negative 6. Make sure you take the sign with that 6. It's negative. And my positive 8 n to the fifth. Negative 6 plus 8 is 2. I can add those together and get 2. But the variable doesn't change. It's still an n. And the power doesn't change. It's still a 5. Cross those out because you're done with them. Now let's scan. And it looks like our next biggest power would be the n to the fourth. So we'll underline those. That's going to be a negative 8 n to the fourth plus 6 n to the fourth. Negative 8 plus 6 is negative 2. Variable doesn't change. Exponent doesn't change. So it's still n to the fourth. Now the next one, as I scan along, I've got a 3 and I've got a 3n. Even though these are both 3's, they are not like terms because this one is an n. And this n is really a power of 1. And this 3 is really a power of 0. So this one is the next biggest power. There is nothing to add to it because those were powers of to the fourth. So this exponent is a 1. It comes next. So I'm just bringing it down. I can't forget about these guys. This is sometimes what people do. If they don't have a like term, they forget to bring down those terms that don't have anything like them, but you can't forget them. Now this 3, this positive 3, also doesn't have anything to add to because it's not a like term, but you can't forget it, so bring it down. It is positive. So bring it down as positive 3. Okay, that one is done. Notice that the powers go in descending order. You have an exponent of 5, an exponent of 4, an exponent of 1, and an exponent of 0. So you're good, you're in standard form. Okay, you have a few to work on your own, and If you have any questions, feel free to ask me. Okay, good luck.